Namaste. Welcome back to the session of Basic Thermodynamics. In the previous session, we have gone through the definition of pure substances, and we have seen importance of saturated lines of that of PV diagram. Let us recall those things and then continue with the PV sketch. We have to go through lot more things in the PV diagram. We have defined a pure substance as a substance which is homogeneous in its chemical composition throughout its mass. In the sense, if given substance has the same chemical composition throughout its mass, then we can call it as a pure substance. And we have seen it may not be a single component. It may be a mixture of two or more components, or it may be a mixture of two or more compounds also. If it is homogeneous throughout its mass, then we will call such substances as pure substances, and we have seen various examples. In that, among those examples, we have chosen water and the mixture of various phases of water as the pure substance. By keeping that in mind, we are going through various phase diagrams. In those phase diagrams, the very first one is a PV diagram. We have gone through few of the aspects of the PV diagram. Let us recall those things and then continue with the next aspects of PV diagram. On the y-axis, I have taken pressure, and on the x-axis, I have taken volume. We can call it as a specific volume per 1 kg of substance. Here we have taken few constant pressure lines. They have named as P dash, P double dash and P triple dash. Let me take one pressure P dash, and I will call this as the 1 atmospheric pressure or 1 bar pressure. If we can understand the aspects at 1 bar pressure, then we can easily understand the rest of the aspects which are happening at higher pressures. Here I have taken the 1 bar pressure, and my pure substance now is water. Initially I will take the solid which is at certain temperature, and we will be continuously providing the heat to that solid. Initially this solid, upon providing the heat, it reaches the saturated point wherein it starts to melt. Once it starts to melt, complete solid gets converted into liquid at point 3. Then it is going to absorb the heat until the water reaches its saturation point, which is nothing but 0.4. Then if you provide the heat, water starts to change its phase, and water particles are getting converted into vapor particles till 0.5. At the 0.5 it will be completely a vapor. Upon substituting the heat continuously, it will reach the 0.6, which is nothing but the superheated state. That we will talk with respect to sketch again. For example, for the understanding purpose, solid is at minus 15 degrees Celsius. This is a temperature at which solid existing. We don't have any restriction on the temperature of the solid over here. Once the heat is provided to the solid, it has to reach its saturated state, which is nothing but the 0 degree centigrade. All these things are happening at 1 bar pressure. We need to keep that in mind. 0 degree centigrade. Upon providing the heat at 0 degree centigrade itself, this becomes liquid. That means from here to here, the solid is getting converted into liquid. Then if you continuously provide the heat, it reaches the 100 degree centigrade, and here it is still liquid. That means the liquid at 0 degree centigrade starts to gain the heat until it reaches the 100 degree centigrade. Upon continuously providing the heat, here we will have conversion. Liquid is going to convert from its liquid phase to the vapor phase. This region is the region wherein liquid is changing its phase until this point. At this point also it is 100 degree centigrade. If you look on to the previous point, it is 100 degree centigrade liquid. In the next point, it is 100 degree centigrade vapor. If I still provide the heat, then this 100 degree centigrade vapor is going to change its temperature. It may be the 150 degree Celsius, say for example. It is an example. We don't have any limit on this temperature. This vapor phase of the water is superheated. Now it is superheated vapor at the 0.6. Here we don't have any temperature restriction, which is greater than 100 degree centigrade at 1 bar pressure. This is less than 0 degree centigrade at 1 bar pressure. On point 1 and on point 6 we don't have any restriction, but at point 2, 3, 4 and 5 we have a temperature restriction at the given pressure. Because of that, point 2, 3, 4, 5 are the state points. Those are the saturated points at which the phase change of the substance is going to happen. That is what is the importance of 2, 3, 4 and 5. So because of that, I mean because at those points the substance is going to change its phase. For that reason we are calling point 2, 3, 4 and 5 as saturated points. So now I have taken this P dash as a 1 bar pressure. If I move on in a vertical direction, in the y direction, that means I am increasing the pressure. If I repeat the experiment for various pressures, then I will get this too. The nature is in such a way that it is going to give the dome for us upon repeating the experiment for various pressures. So now this is the P double dash. At P double dash I have marked the same 6 points, and this is P triple dash. On P triple dash also I have marked the same 6 points. Corresponding points needs to be named in the same fashion. Since it is P dash, this is P 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. That is P double dash, 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash, 6 double dash, and the last pressure is a triple dash. Please make sure you will write the same notation for all the points. Now here also 1 double dash and 6 double dash, we don't have any limits on the temperatures, whereas 2 double dash, 3 double dash, 4 double dash, 5 double dash are the saturated points. Here also 2 triple dash, 3 triple dash, 4 triple dash, 5 triple dash, all these points are saturated points. Now if you join the saturated points as you get upon the experiments, we are going to get saturated lines. Joining of saturated points is going to lead to saturated lines. That means what? These saturated lines are going to give us saturated points at various pressures. That is what is a saturated line. Upon joining the saturated points, what are the saturated points? 2, 3, 4 and 5. We have 4 saturated points. Because of that, joining of 4 saturated points at various pressures will lead us to 4 saturated lines. What are those saturated lines? Very first one is a saturated solid line, saturated liquid line 1, saturated liquid line 2 and saturated vapor line. Let us look on to one by one now. First one is a saturated solid line. Second one is saturated liquid line 1. Third one is saturated liquid line 2 and the fourth one is saturated vapor line. Now let us look on to this saturated solid line. Concentrate on the P dash pressure, which is nothing but 1 bar. I have taken an example over there. Ice at certain temperature, upon providing the heat, it reaches the saturated point, which is nothing but the point 2 dash. Now if I still provide the heat, it is going to change its phase from solid to liquid in the region 2 to 3. That means in the region 2 to 3, the substance is changing its phase from solid to liquid. That is why in that region we will get solid and liquid. That means point 2 is a saturated point, point 3 is also a saturated point in which phase change is going to happen. If I move little bit away from the point 2, its phase changes. If I come back little bit behind the point 3, again phase change happens. Because of that, 2 and 3, I mean 2 dash and 3 dash are saturated points. Now what is this line is indicating us? Saturated solid line, in the sense if I move little bit away from this line, the solid is going to melt. Solid starts get converting into liquid. That means upon this line the solid will, I mean the substance will remain as a solid. That is the saturated line. In the sense if we move little bit away from this line, the substance starts to change its phase. That means the substance will not be remained as a solid, it will get converted into liquid. That means what? this is the end point for the, this is the end line for the solid to remain in its solid position. Because of that, the line is named as saturated solid line. Saturation of the solid is going to happen on that line. If you move a little bit away, then it will get converted into liquid. Phase change happens. That is what saturated solid line is. Next, this is saturated liquid line. From 2 to 3, what is happening? Solid is getting converted into liquid. If I move little bit behind the point 3, then the liquid which is at 0 degree centigrade at point 3 dash is going to get again converted into solid. That means at point 3 the substance is in its liquid form at 0 degree centigrade. At point 2 the substance is at 0 degree centigrade in its solid state. If I move little bit behind the point 3 dash, then which is nothing but the phase change of the liquid which starts to happening. That means the saturation point, change in the saturation point is leading the phase change of the substance. Because of that, this line is also called as saturated liquid line, because on this line the substance will be liquid. If you move little bit behind that line, then the substance will be a mixture, solid plus liquid mixture. If you want complete liquid, then you need to be on this line on various pressures. Because of that, that particular line is called as saturated liquid line, and we have named it as 1, and it is also with respect to the saturated liquid line 1, and this is saturated liquid line 2. Okay. Now if I continue to provide the heat from 3 dash to 4 dash, what is happening from 3 dash to 4 dash? Look onto this. Here the substance is liquid at 0 degree centigrade. Now if I continue to provide the heat, the liquid is going to absorb the heat till again one more saturated point is liquid, but the phase change is not happening. At saturated point 4, the liquid, the substance is in its liquid phase. Even at 0 degree centigrade it is in liquid phase, even at 100 degree centigrade it is in liquid phase. If I move little bit beyond the 100 degree centigrade, then it is going to change its phase. So because of that, these lines these points 4 dash, 4 double dash, 4 triple dash forms one more saturated line, which is nothing but saturated liquid line 2. We need to be very careful over here. The lines formed by point 3 is also saturated liquid line. The lines formed by point 4 is also saturated liquid line. Now we need to look onto the process. If I go little bit behind the 3, the liquid is going to condense and it starts becoming solid. If I move little bit beyond point 4, the liquid starts to evaporate. Its phase changes into vapor. Because of that, the liquid line 1 is, saturated liquid line 1 is nothing but saturated liquid line with respect to solidification. What is that process which is happening? If you move little bit behind point 3, solidification is happening. If you move little bit beyond point 4, vaporization is happening. So because of that, this is, saturated liquid line 2 is nothing but saturated liquid line with respect to vaporization. Now, still supply the heat from 4 dash to 5 dash, the heat will be absorbed by the substance, and 5 dash is the saturated point again. Now look onto this, 100 degree centigrade liquid and 100 degree centigrade vapor. Liquid changes its phase to vapor. The substance changes its phase from liquid to vapor, but temperature is not changing. It remains same, which is nothing but 100 degree centigrade. If I move little bit away from the 100 degree centigrade, the phase change is happening and the substance is completely vapor. That means here it is completely liquid, here it is completely vapor. That means in this region it is a liquid plus vapor. If I move little bit away from point 4 dash, it is a mixture. If I move little bit behind the point 5 dash, it is a mixture again. If I on the line phi dash, phi double dash, phi triple dash line, then it is a complete vapor. That means if I move little bit behind the point phi dash, again the phase change of the substance is occurring, it becomes the mixture instead of dry vapor. Because of that, this line is considered as saturated vapor line with respect to what? If you move little bit behind phi dash, it will get condensed back into liquid from vapor. That is why it is called as condensation. The saturated vapor line with respect to condensation. So now saturated solid line, we need to name this line also. That saturated solid line is formed by point 2. Now look onto this, if I move little bit away from point 2, what is happening? Solid is getting converted into liquid. That means solid is melting. The line name is saturated solid line with respect to melting. These are the names for saturated lines. Please concentrate on this. Saturated solid line with respect to melting, saturated liquid line with respect to solidification, saturated liquid line 2 with respect to vaporization, saturated vapor line with respect to condensation. So these are the 4 different saturated lines what we have obtained at saturated points for various pressures. Now let us try to look onto the importance of these lines. Before that, one thing is for very sure, in our basic thermodynamics we will be looking or we will be concentrating on liquid, liquid plus vapor as well as vapor regions. That means we are least bothered about the solid phase of the substance. The reason is the solid phase of the substance will be completely taken care by other subjects such as material science and metallurgy. We have left the solid phase of a substance over there and we will be concentrating on only liquid, liquid plus vapor and vapor portion. So let us try to keep this in mind and then let us look on to the importance of these lines. Now concentrate on these regions. The region which is marked as L to the left of saturated liquid line, this region, liquid line, which region is nothing but, we used to call that region as a subcooled region. In the sense, in this region, if you completely look onto this region, in this region, at any pressure, in this region at any pressure, the substance will remain as liquid only irrespective of in which pressure you are operating the substance. The region which is marked to the left side of saturated liquid line is nothing but the liquid line. That means irrespective of the pressure, the region will be holding the liquid form of the substance. So this particular region is nothing but subcooled region. Next region is this region, liquid plus vapor, which is nothing but mixture region. Mixture region in the sense, if you look on to any pressures, P dash, P double dash, P triple dash, at all the pressures inside this dome, I will be having liquid plus vapor. Such a region is called as mixture region. Next region is superheated region. Superheated region in the sense which is nothing but the vapor region, which is marked to the right of saturated vapor line. This is the saturated vapor line. The region which is marked as V towards the right of this line is nothing but the superheated region. That is what is the superheated region. And the last region is the sublimation region. This we haven't talked at. Sublimation region is nothing but this region. I will come back to this region at the end. Now let us look on to the subcooled region. What is happening in the subcooled region? This portion is the subcooled region. In this portion, if you look on to the temperature, please look on to the temperature at this region, irrespective of the pressure, inside this region, the temperature of a substance is less than a saturation temperature of that substance at that particular pressure. Look on to the temperature at this region. Temperature is less than the saturation. Where saturation temperature comes? At 4, 4 dash, 4 dash, 4 double dash, 4 triple dash. And that means irrespective of the pressure, the temperature is less than the saturation temperature in subcooled region. Next, if you move on to the superheated region, at any pressure, the temperature of the substance is greater than its saturation temperature. Please look on to the region. These are the saturated points. The temperature of a substance is greater than the saturated temperature in the superheated region. So here it is less than the saturation temperature. In this region it is greater than the saturation temperature at any pressure. You can look on to any pressure. In that region, the temperature of the substance is greater than the saturation temperature. In this region, the temperature of the substance at any pressure is less than the saturation temperature. And then in this region, the temperature remains constant, wherein the phase change from liquid to vapor is happening. So that is what is the mixture region, wherein you can have the liquid plus vapor region. Next region is a sublimation region. If you look onto this, on this side we have solid. This entire portion is solid portion. This entire portion is solid portion. If we heat the substance below triple point line, please concentrate on this term. If we heat the substance below triple point line pressure, this is also a pressure line, triple point pressure line, then the substance directly get converted into vapor from solid. Look onto this, from solid to vapor it will be directly getting converted by skipping liquid region. Please concentrate on this again. If we heat the substance below triple point line pressure, then the substance is going to skip the liquid region. Instead of getting converted into liquid, the solid directly gets converted into vapor. Such a region is called as sublimation region, wherein solid directly get converted into vapor by skipping liquid region. So those are the importance of various regions. You can now look onto this. The solid liquid line is going to separate solid from liquid. The solid vapor, liquid vapor line, saturated line is going to separate liquid from vapor. Look onto this. On this line, it is a saturation vapor line. If you come little bit behind this line, you will have the liquid vapor line. That means this is the line which is separating liquid and vapor. In the same fashion, this is the line which is separating solid and liquid. Solid liquid saturation line is going to separate solid and liquid. Liquid vapor saturation line is going to separate liquid and vapor phases. And those are the few importance of various regions that are existing on PV diagram. So these are the things related to saturated lines, and these are the things related to various regions. Now let us concentrate on, we have written 2 points over here, critical point and triple point. Let us concentrate on these 2 points now. Okay, let us look on to the various points that we have marked over here. One is a CP and another one is a TP. Let us concentrate on CP now. The expanded form of CP is nothing but critical point. If we clearly observe this sketch, the saturated liquid line and the saturated vapor line are merging at a single point. That particular point has been named as a critical point. So very first thing is the point in which the saturated liquid line and saturated vapor line merges. This is the beauty of the nature. Next thing is, if you clearly look onto the critical point, it is the point at which it is highly difficult to distinguish between liquid and vapor phases of same substance. If I ask you a question, what is the phase of a substance at critical point? We are unable to answer. It is the point in which there is no differentiable thing at various phases of substance. So, critical point is a point in which no distinguish between various phases. So, that is the second observation at that point. Now, if you clearly observe over there, it is looking like a point to us on a particular pressure line. This is say some pressure on a particular pressure line. This particular point is lying. That means we have a pressure line over there. On the line we have a point. That means, say for example, at this pressure, in order to move from 4 double dash to 5 double dash, I need to supply the heat. On this pressure line, in order to move from 4 triple dash to 5 triple dash, I need to supply the heat. But here, you don't have to supply the heat at all. It is the point in which no heat is supplied to the substance to convert its phase. The point in which no heat substitution is required. No heat supply is required. It does not demand the heat supply to change its phase. So, those three are the three important points that we can observe at this particular point. Very first one is merging of two saturated lines, which are nothing but saturated liquid line and saturated vapor line. And the second thing is, it is highly difficult to distinguish between the phases of the substance. And third thing is a point in which no heat is required to convert the phase of a substance. Such a point is called as critical point. You can define the critical point by all those three aspects. Critical point is a point in which there is no distinguish between the various phases of a substance, or it is the merging point of two saturated lines, or it is the point at which no heat is supplied to a substance. So, this is what is the critical point. For a water, we have certain value for critical point. So, critical pressure, for water I am talking, critical pressure is about 220.9 bar. In the same fashion, critical temperature is about 374.14 degree Celsius. What is the values of pressure and temperature at this point? For a water, it is 220.9 bar and 374.14 degree Celsius. These are the critical pressure and temperature for the water, at which no distinguish between the various phases of the substance. So, that is what is related to the critical point. Next thing is a triple point, which is denoted as TP, triple point. As the name itself indicating, there are three different aspects in that point. Now, you can ask the question, triple point, I have written this line as the triple point. The name is a point, but I am showing it as a line. Here, point in the state, in the sense, it is a state or line. Don't get confused over here. Triple point in the sense I am not talking with respect to the point. It is the state of the substance, or it is nothing but the line in this particular situation. Don't get confused over here. Triple point, state, or triple point, line. The meaning of the triple point itself is triple point state or triple point line. Why it is called as the triple? Because it is the point in which all the three phases, what are those neutral phases of a substance? Solid, liquid and gaseous phase. All these three phases are going to coexist in equilibrium. In the sense, on this line, on this state, all the three phases of a substance is going to coexist, in the sense the substance may exist in the form of solid, may exist in the form of liquid, or may exist in the form of gas. It may exist in all the three phases also. That is what is the meaning of triple point. Point at which all the three phases are merged or coexist in the equilibrium fashion. We have a triple point critical values also, I mean triple point pressure as well as triple point temperature also. So triple point pressure is nothing but 0.00613 bar. In the same fashion, triple point temperature is nothing but 0.01 degree Celsius. So these two are the triple point pressure and triple point temperature for the water. It is the pressure at which corresponding temperature is this much. I mean at this pressure and at this temperature, the substance or the water will be in its triple point phase. All the three phases of the water will be coexisting. In the same fashion, this is the pressure and this is the corresponding saturation temperature. This is the pressure and temperature at which the water reaches the critical state. So these two are the two different points which hold their own importances at various stages. So these two are with respect to the two different points. Now let us talk with respect to the various processes that are happening in a substance. Very first thing is melting that we have seen. From where melting is happening, this is the P dash line. Let me write the P dash line now. This is the P dash line. 1, 2, 3, 4, 5 and 6. We knew 1 and 6 are not the state points, 2, 3, 4 and 5 are the state points. From here to here it is melting, from here to here it is absorbing the heat, from here to here it is boiling, from here to here it is superheating. So now very first thing is melting. What do you mean by melting? Melting is nothing but the absorption of heat by the solid and it changes its phase from solid to the liquid. So that is what is melting phenomenon. So solid phase of a substance will be getting converted into liquid. So that is what is melting for us. Next thing is boiling. What you mean by boiling now? At 1 bar pressure, at 4 dash the water is at 100 degree centigrade, at 5 dash the water is at 100 degree centigrade only, but here it is not in the form of water, which is in the form of water vapor. What is happening from 4 dash to 5 dash? What is happening from 4 to 5? Which is nothing but boiling. The substance is receiving the heat and it starts to boil and the phase change is going to happen. That means boiling is a phenomenon in which the substance changes its phase from liquid to vapor. It is also called as vaporization. Boiling is another term which holds a different meaning, even though on the surface level it is the phase change from liquid to vapor, vaporization. That is what is boiling to us. And next thing is vaporization. We have seen this. And one more thing here is solidification. On the reverse contrast, we have solidification. What do you mean by solidification over there? If solid gets converted into liquid, I will call it as a melting. If liquid gets converted into solid, from where to where it is happening? Look onto this. From 2 to 3, here it is at 0 degree centigrade, here also it is 0 degree centigrade, here it is 100 degree centigrade, here it is 100 degree centigrade, it is greater than 100, this is less than 0 at 1 bar pressure. So now, if I move from 2 to 3, I will call it as melting. If I move from 3 to 2, I will call it as solidification, in which liquid gets converted into solid. Now, in the same fashion, if you move from liquid to vapor region, I will call it as a vaporization. If I move from here it is solid, here it is liquid, here it is liquid, here also here it is vapor. If I move from liquid to vapor, I will call it as a boiling or vaporization. If I move back from vapor to liquid, certain phenomena should be there. If I move from vapor to liquid, then it is called as condensation. The process is nothing but the condensation, in which vapor is going to convert it into a liquid. All those four processes should be very clear with us. Melting is the process of conversion of solid to liquid. If I move in a reverse fashion, if I move from liquid to solid, I will call it as a solidification. If I move from, if the phase change happens from liquid to vapor, I will call it as a boiling. If a phase change happens from vapor to liquid, then we will consider it as a condensation. So we should be very careful with all these processes. Okay, let us look on to the other aspects now. We know if we move from point 2 to 3, let us look on to this. Point 2 to 3, the melting is happening. From point 4 to 5, the boiling is happening. If I move in a reverse fashion from 5 to 4, which is nothing but the condensation. If I move from 3 to 2, it is nothing but the solidification. So now, here if I write the phase of substance, solid, this is liquid, liquid, vapor, superheated vapor, and here also it is solid. So now, if you look onto the various processes, certain amount of heat has to be absorbed by the substance to change its phase. Now, from solid to liquid, the phase change is happening. Am I right on that? From 2 to 3, the phase change is happening. From liquid to vapor, again phase change is happening. Certain amount of heat needs to be supplied over here to change its phase. Certain amount of heat needs to be supplied over here to take the substance to its saturated state. Certain amount of heat needs to be added over here to change the phase. Again, certain amount of heat is added to change the saturated thing into superheated states. So let us look on to the various kinds of heat. To that particular region, what is the amount of heat is supplied? That has been named as different types of heat. Very first thing is sensible heat. Sensible heat, in the sense, it is the amount of heat supplied to a substance in a single phase. What do you mean by that? From 2 to 3, solid and liquid phases are existing. In a liquid region, from 3' to 4', it is completely a liquid region. It is a single phase region. Liquid region is a single phase region. Here vapor region is a single phase region. No phase change is happening. Here solid region is a single phase region. No phase change is happening. Whereas solid plus liquid, phase change is happening. Liquid plus vapor, phase change is happening. My definition to sensible heat is amount of heat absorbed by the substance in a single phase, or it is the amount of heat supplied to a substance to take it from a state to its saturated state. These two things should be very clear with us. So it is the heat absorbed by the substance in a single phase from given state to saturation state. So this is the condition. Amount of heat absorbed by the substance in a single phase in order to convert it from given state to the saturation state. So what are the sensible heats that we are applying over here? From 1 to 2, single phase region, so it is a sensible heat. From 3 to 4, it is the sensible heat, SH, sensible heat is denoted as SH, and from 5 to 6, it is vapor region, SH. That means here a single phase, sensible heat. Here it is a single phase. From 3 to 4, sensible heat. From 1 to 2, single phase, sensible heat. Sensible heat is nothing but the heat absorbed by the material or substance in a single phase. Second thing is latent heat. This latent heat is nothing but amount of heat absorbed by the substance in order to convert its phase, in order to change its phase. If you look onto the change of phase, from 2 to 3, solid is getting converted into liquid. From 4 to 5, the liquid is getting converted into vapor. In the sense, from 2 to 3 and from 4 to 5, the substance is changing its phase. In that portions, what is the amount of heat absorbed by the substance, which is nothing but the latent heat. It is nothing but the not a single phase heat supplied, or it is a dual phase or multi-phase, you can say, multi-phase. To change the phase, what is the amount of heat that is supplied. So now here we have various aspects also. Look on to this 2 to 3. From 2 to 3, what is happening? Melting of the solid is happening. Melting of the solid is happening. Phase change is happening. Such a heat which is responsible for conversion of solid into liquid is considered as latent heat of melting. What do you mean by latent heat of melting? The amount of heat supplied to a substance in order to change its phase from solid to liquid at constant pressure as well as at constant temperature. Such a heat is nothing but latent heat of melting. Reverse is also true. From 3 to 2, if I come from 3 to 2, again phase change is happening from liquid to solid. What is happening? Liquid is getting converted into solid. Such a heat is considered as latent heat of solidification. Latent heat of solidification. What is happening in melting? Solid is getting converted into liquid. What is happening in solidification? Liquid is getting converted into solid. Make sure in all the latent heats, two phases should exist. Next thing, from 4 to 5, what is happening? At the 4, it is a saturated liquid. At the 5, it is the saturated vapor. In the sense, amount of heat absorbed by the substance to change its phase from saturated liquid state to saturated vapor state. Such a heat is called as latent heat of vaporization, evaporation, vaporization. What are the two states? Liquid and vapor. If liquid is getting converted into vapor by absorbing the latent heat at constant pressure and at constant temperature, then I will call it as a latent heat of vaporization. Reverse is also true. If you come from 5' to 4', the vapor is getting converted into liquid. Such a heat which has to be rejected by the substance is considered as latent heat of. What is happening over there? What kind of process it is? If you convert vapor into liquid, which is nothing but condensation. So, latent heat of condensation. Vapor to liquid. So, these are the 4 different latent heats in which you can see the phase change of a substance. It is very clear, latent heat is the heat which is supplied to a substance to change its phase. If solid to liquid, latent heat of melting. If liquid to solid, you need to remove the heat, which is nothing but latent heat of solidification. Liquid to vapor, in the sense you need to add the heat, which is nothing but latent heat of vaporization. Vapor to liquid, in the sense you need to remove the heat, which is nothing but latent heat of condensation. These things are also named by other name: enthalpy of melting, enthalpy of solidification, enthalpy of vaporization, enthalpy of condensation. These are also named by enthalpy of respective things. Enthalpy of melting, enthalpy of solidification, enthalpy of vaporization, enthalpy of condensation. The definition will be the same thing. So, this is the latent heat, which is nothing but the second kind of heat. And the next heat is a superheat. The name itself is saying, here also it is superheat, SH. You need to superheat it. The amount of heat which is supplied to a saturated vapor to change its, to increase its temperature to the superheated region. Look on to the region 5 to 6, no phase change is happening. No phase change is happening in the sense it is also a single phase heat supply. It is also a single phase heat supply, but here vapor is getting converted into superheated vapor. The temperature of the saturated vapor will be increased to superheated temperature. Such a heat is considered as superheat. 5 dash to 6 dash, 5 double dash to 6 double dash, 5 triple dash to 6 triple dash. All these increment in the temperature is because of application of superheat to the substance. So it is very clear, saturation temperature will be rise to superheated temperature. So that is nothing but the superheat. All the things are very clear. Sensible heat, heat supplied in a single phase wherein phase change is not going to happen. It is the heat required to take the material from the existing state to saturated state. Latent heat, amount of heat required to change the phase of the substance. We have 4 different types of latent heats. Superheat, already existing saturated vapor needs to be taken into superheated state. Such amount of heat is called as superheat, and it is also a single phase heat. So these are the 3 different forms of heat that needs to be supplied into the substance. And the last thing is a degree of superheat. One more term we are left out with, degree of superheat. Superheat. In short form you can call it as DOS. This DOS, degree of superheat, is nothing but difference in temperatures. Temperature superheated minus saturation. I hope it is very clear now. Here it is 6 dash, 5 dash, 6 double dash, 5 double dash, 6 triple dash, 5 triple dash. The difference between the superheated temperature and the saturation temperature is nothing but the degree of superheat at that particular pressure. In the 1 bar pressure, 6 dash minus 5 dash. In greater than 1 bar, 6 double dash, 5 double dash, in such a fashion. That is what is degree of superheat. Difference between the superheated temperature and the saturation temperature at a constant pressure is nothing but the degree of superheat. I hope this is very clear, which is last thing with respect to the superheat. Difference between the superheated temperature and the saturated temperature. So these are the various kinds of heat that you can define with respect to the PV diagram. So with this, we are ending up with almost all the information which are related to the PV sketch. Initially we have gone through the saturated states, then saturation lines, then various regions, then critical point, triple point, then various types of heat that are required to change the phase of the substance or to keep the substance in its single phase. So this is what is the information which are related to the phase change diagram, which is nothing but PV diagram. In the next session, we will be looking onto the other phase diagrams. For this session, this is what I have. Let's meet in the next session. Until then, namaste.